So in this lesson, we are going to be working with circles on the coordinate plane. And obviously circles are not functions. We've been working with quadratic functions, but they are a quadratic type relation, and you'll see why in a minute. First of all, let's start by defining a circle. A circle is the set of all points that are equidistant from a fixed point. So that equidistance is the radius, and that fixed point is the center. For example, if we went in our yard and we put a stake in it and we attached a rope to it that was a certain length, we could pull that rope tight and walk around and make a perfect circle. All right, so here's the equation of a circle, and I want to talk about where this comes from. So let's see where this formula comes from. The distance from the center to any point on the circle is the radius. Well, let's say we have some center HK, and we'll just call any point on the circle XY. If we want to find the horizontal distance between the center and that point, we could see right here that we're going from a distance of H to a distance of whatever X is. Now, because this is a real problem, we can see that that would be from 2 to 5, and we would know that that distance was 3. But let's say we didn't know that, and it could be any number. If I wanted to find that distance, I would take the 5 and subtract 2. 5 minus 2 gives us 3. So since we don't know what those numbers are, what we do is we say, okay, well, to represent this horizontal distance, that would be x minus h. Remember, the x value on the circle minus the x value of the center. And then the same thing goes for the vertical distance. We're trying to figure out how high are we going from the center of the circle to that point. Well, again, we can see that these numbers are 2 and 5, so we know that that height's 3. But what if it was any circle, and it wasn't necessarily 2 and 5? We would do the same thing we did in the last one. So to get that vertical distance that we traveled right here, it would be the y-coordinate minus the y-coordinate of the center, so that would be y minus k. It's kind of like slope. You're doing the change in x and the change in y. Well, as you can see, this makes a little right triangle in here, so we can apply Pythagorean theorem, and Pythagorean theorem tells us that leg squared plus leg squared equals hypotenuse squared. So when we substitute that in, that gives us x minus h quantity squared for that horizontal distance squared, plus y minus k quantity squared for that vertical distance squared, equals r squared. So the circle formula is really just derived from Pythagorean theorem. It's the same thing as the distance formula. It is derived from Pythagorean theorem. Anytime we are trying to write the equation of a circle, we want to get it into this standard form, x minus h squared plus y minus k squared equals r squared, where the center is the hk, so we'll always take the opposite of what's inside, and the radius is equal to r. All right, so notice this first problem that we have. X squared plus y squared plus 16x minus 22y equals 20 equals 0. Okay, so we look at that and we're like, whoa, that is not in the correct form. So how do we get it in the correct form? Well, it's kind of like going from the standard form of a quadratic function to the vertex form of the quadratic function. We're going to have to complete the square. So the difference in this case then when we do the parabolas is in these we have x squared and y squared. So we're actually going to complete the square for the x's and for the y's if they both have linear terms. So to start out, what you want to do is you want to group your x terms together. So we're going to have x squared plus 16x. And since we know we have to make this into a perfect square trinomial, go ahead and put plus blank. And then we're going to group our y terms together. Plus y squared minus 22y plus blank. Because again, we know we've got to make that into a perfect square trinomial. And then we've taken care of all our x terms and our y terms, but we have this minus 20 on the left-hand side. So we're going to add that minus 20 over to the right-hand side. And then we know the golden rule of working with the equations is what we do to one side, we must do the other. So since we're going to add blank to the x's, we got to add it over to the right side too. And since we're going to add blank to the y's, we got to add it over to the right side too. So if we add 2 blanks to the left, we must add 2 blanks to the right. Once you set that up, it's pretty simple. It's just following those completing the square steps. We know we're going to take half the coefficient of the linear term, so half of positive 16 would be positive 8. We then square it and add it back. And what we do to one side, we must do to the other. And then we do the same thing for our y's. Half of negative 22 is going to be negative 11. And then we square it and we add it back. And what we do to one side, we must do to the other. And then we're going to come over here to the right-hand side and clean that up. So 20 plus 64 plus 121 is 205. And now we have it in our circle formula, so we can pick out the center and we can pick out the radius. So in this case, the center of this circle would be negative 8, positive 11. You always take the opposite. It's kind of like when we're doing our transformations. Anytime it's inside, you always do the opposite of what you think. So it would be negative 8, positive 11. And then the radius, remember, this is equal to r squared. So to get the radius, you would have to take the square root of 205. Advice would be when you're doing one, and since we're just learning this formula for the first time, write the formula under it when you get it in the correct form so that you pick out everything correctly. All right, so what I would like for y'all to do now is I would like for you to pause the video and complete the square so that you get it into our circle formula. Once you've done that, start the video back. Pause now. Okay, so just like the last one, what we're going to do is we're going to group our x terms. So we have x squared plus 2x plus blank plus y squared plus 4y plus blank. And then we're going to add that 11 to the other side. And since we have 2 blanks on the left, we're going to have 2 blanks on the right. And then we go into our completing the square. So if you want to go ahead and set it up, we know we're going to do it for our x's in this case, and also for our y's. So we can go ahead and set up those binomial squareds. So to do this, we're going to take half the coefficient of the linear term. So half of 2 is 1, square 1, and add it back. Make sure what we do to one side, we do to the other. And then half of positive 4 is positive 2. Square it, that gives us 4, and add it back. So in this case, this will come out to equal 16. And that is our standard form of a circle. So the next step is we want to graph it. And to graph it, we need to pick out the center and the radius. So in this case, the center of this circle, remember we take the opposite, is going to be negative 1, negative 2. And the radius of this circle, you always got to take the square root of what it's set equal to, because that's r squared, is going to be 4. And so to graph this, we're just going to go over to our graph paper. We're going to plot the point negative 1, negative 2. And then we're going to count right 4 units from the center. We're going to count up 4 units from the center, left 4 units from the center, and down 4 units from the center. And then to the best of our ability, we are going to try to draw a circle. Do the best you can. I know they're not going to be perfect, but try not to make it look like a square. Try to make it circular. And then there's our circle. All right, so the next one is we're going to start getting into writing equations of circles. So write an equation of a circle if the endpoints of a diameter are at negative 7, 11, and 5, negative 10. Well, guys, what you have to remember is every diameter, and a circle has an infinite number of diameters, but every diameter cuts the circle in half. So the diameter has to pass through the center of the circle. And the center of the circle is what cuts that diameter into 2 equal parts, which are the radius. So our step 1 is going to be to get the center of the circle. And all you have to do that is find the midpoint of that diameter. The center of any circle is always going to be equal to the midpoint of any diameter of that circle. So going back to our knowledge from Math 1, and you probably did it some last year in Math 2, all we have to do to find midpoint is average our points. It's the point in the middle. It's just the average. So we add our 2x values together and divide by 2. And we add our 2 y values together and divide by 2. So negative 7 plus 5 divided by 2, that is going to give us negative 2 divided by 2, which would be negative 1. And then 11 plus negative 10 divided by 2, So that's going to be 1 divided by 2, which is 1/2 or 0.5. And that gives us the center of our circle. All right, well, here's the deal. We know our formula is x minus h squared plus y minus k squared equals r squared. So when we find that center, we already have our h and k. So we can go ahead and substitute that in. We know that this is going to be plus x plus 1 quantity squared plus y minus 1/2 quantity squared is equal to, the problem is we don't know what r squared is. We don't know the radius. So there's a couple of ways to do this. One, sometimes students will graph one of the endpoints of the diameter, because remember, if it's the endpoint of a diameter, it's a point on the circle. And they'll graph the center, and they'll use Pythagorean theorem to get that radius, and then pop it in. Some students will find the distance, using distance formula, between one of the endpoints of the diameter and the center, and they do it algebraically, and they get the radius. Some students will find the distance of the whole diameter and then divide it by 2 to get the radius. But what I think is the easiest way to do it is remember that if you know the endpoints of the diameter, those are points on the circle. So pick one of them, and I'm going to pick the point at 5, -10, and substitute it into your formula for x and y. Remember, every point on the circle represents xy. That's what xy stands for. So what I could do is substitute these values in for x and y and figure out what r squared is. Because guys, ultimately your circle formula is the same as your distance formula. It's just in a different form. It's the same as Pythagorean theorem, which is why I went through Pythagorean theorem in the beginning. So what I'm going to do is substitute this in right here. So that is going to give me 5 plus 1 quantity squared plus -10 minus 1/2 quantity squared equals r squared. And if we calculate that, you can use your calculator or, and you can write it as a fraction or as decimal, but it comes out to be 585 all over 4. You can just type it right in, equals r squared. And a lot of times students will want to go ahead and take the square root and get r, but remember, all we're trying to do is write the equation. So once we have r squared, we just got to put it back together. So our final answer would be x plus 1 quantity squared plus y minus 1/2 quantity squared equals 585 over 4, because we want to set it equal to r squared. And to me, that's the quickest way to come up with the equation, even though there's other ways. All right, so now we're going to get into some systems with circles. The next one says, find the exact solution or solutions of the system of equations. Well, first of all, you want to think about what you have here. You're given an equation of a line, an equation of a circle. And this particular circle, notice it doesn't say like x minus 3 squared or y plus 1 squared. So what that means is it's centered at the origin. Anytime you just see x squared or you just see y squared, it means that the h and k value were 0. So if we kind of just did a little idea of what this might look like, what happens is we have a circle who has a center at the origin, and it has a radius of 5. Because remember, you have to take the square root. This is equal to r squared. So this particular circle is in the form x squared plus y squared equals r squared, and any circle centered at the origin will have that form. So pretty much we have a circle with the center at the origin, and it has a radius of 5. It looks something like this. And then we've got this line, y equals x plus 1. So we know this line goes through the y-axis at 1 and has a slope of 1 over 1. So it's going to look something like this. The reason why I go through this is because that at least lets me know I'm looking for 2 solutions. There are 2 different points where this circle intersects that line. All right, so we're going to work this out algebraically, and to do that, we're going to use substitution. If we know that y is equal to x plus 1, when we go over to this circle formula, we can substitute x plus 1 in wherever we see y. So we have x squared plus y squared, but instead of putting y, we're going to substitute in what y is equal to, which is x plus 1 squared equals 25. And then we're going to do our algebra and work this out. So that is x squared. Remember, anytime you see a binomial squared, you have to write it twice and FOIL it. Some of y'all might want to do that over to the side, or you can go over to the side and box it if that's the way you like to do it. So that gives us x squared plus 2x plus 1 equals 25. All right, the next step is we want to clean this up and set it equal to 0. So that gives us 2x squared plus 2x plus 1 equals 25. When we subtract 25 from each side, we get 2x squared plus 2x minus 24 equals 0. Now that I'm solving this equation and I realize that all of our numbers are divisible by 2, I'm going to divide this entire equation by 2 and make it a little bit easier on myself. So that gives us x squared plus 1x minus 12 equals 0. And if we use our factoring technique, we're looking for two factors that multiply to negative 12 and add to positive 1. So that would have given us, I'm just going to rewrite this over here real quick, that would give us x minus 3 times x plus 4 equals 0. So we get x is equal to 3 and x is equal to negative 4. Once we get our two different x values, we need to substitute them back into one of the equations to figure out what y is. Well, guys, think about it. It's going to be a lot easier if we substitute back into the linear equation than the circle equation. It'll be a lot less work. So I'm going to just write this down here. When x is 3 and when x is negative 4, and I'm going to write the equation of our line, y equals x plus 1. So if x is 3, when we substitute into this equation, we get y is equal to 3 plus 1, which is 4. And when x is negative 4, if we substitute that into this equation, we get y is equal to negative 4 plus 1, which is negative 3. So therefore, our 2 points where these intersect is at the point 3, 4, and at the point negative 4, negative 3. And guys, I promise if you substituted those points into both equations, they would make both equations true. Think about this, x squared plus y squared equals 25. 3 squared plus 4 squared definitely equals 5 squared. That's our most famous Pythagorean triple. And if you want to look at it, the graph, that was the point 3, 4, and this was the point negative 4, negative 3. Now, of course, my graph is not accurately drawn. It's just there to help us out. Okay, so I would like for you to try this one on your own. Think about what each equation represents and what it could possibly, how many possible solutions could you have. When you're finished, start the video back. Pause now. Okay, so in this one, we have a parabola, which has been, or like our parent graph shifted down 3, and a circle that has a center at the origin with a radius of 9. So if we draw a little diagram, we can clearly see one of the intersections would be at 0, negative 3. But I'm not really sure exactly where the other two are. I know that one's in the first quadrant and one's in the second quadrant, but we need to find it. So this is where we're going to do our algebra work. To do this, the easiest way is to add the 3 over in our first equation right here. So I'm going to make this y plus 3 equals x squared. And then when I go over to my circle formula, I can actually substitute y plus 3 for x squared. So right here where we have x squared, we can just put y plus 3, and then we'd say plus y squared equals 9. Notice I'm not squaring it because I did a direct substitution there. Well, then we have a quadratic equation, so that would be y squared plus y plus 3 equals 9. And then when we subtract 9 from each side, we have y squared plus y minus 6 equals 0. The two numbers that multiply to negative 6 and add to positive 1 are negative 2 and positive 3, so our factors are y minus 2, y plus 3. And then when we set those equal to 0 and solve, we get y is equal to 2 and y is equal to negative 3. Then once we know what that is, we need to substitute it back into one of our equations to figure out what x would be. Well, since we went ahead and moved this around and we know that x squared is equal to y plus 3, we could use that fact. If x squared is equal to y plus 3, then right here, when we substitute that in, that would make that x squared equals 2 plus 3, which is 5. And then when we take the square root of each side, don't forget your plus or minus, we get that x is equal to plus or minus the square root of 5. So that gives us the point negative square root of 5, 2, and positive square root of 5, 2. And those are these points right here and right here. They don't always come out to be pretty. And then if we were to substitute negative 3 in, when we say negative 3 plus 3, we get 0 is equal to x squared. And when you take the square root of 0, you just get 0. And we already knew that was a point. We already knew that if you did the graph first, or a little sketch of the graph, that we have an intersection at the point 0, negative 3. So in this case, we have 3 intersections, and those are it. Think about it. Sometimes when you do a parabola in a circle, you might only have 2 intersections. You could have only 1 intersection. We could have 4 intersections. We could have no intersections. So that's why I like to kind of draw a sketch of the graph. It might not be perfect, but it gives me an idea of how many solutions we're looking for. All right, the last part is to graph systems of inequalities. So again, start by looking at what we have. The first one we should recognize as a circle. I know it says less than, but we're going to be graphing a circle. The next 2 are linear inequalities. Now the first thing you're going to need to do is on that second one, solve it for y. So go ahead, pause the video and do that now. If we solve that one correctly for y, we should get y is less than or equal to 2x minus 4. Remember, when you multiply or divide by a negative, it flips that symbol. So when we subtract that 2x over and then divide the whole thing by -1, it flips the symbol and changes all the signs. All right, so the first one we've got a center at 0, 0. You might want to write some of this stuff out. And it has a radius of 7. Remember, you always take the square root. So let's graph that on our paper. So this is an inequality. So remember, you got to think about, should this be a dashed or solid, and it's not lines in this case, but curve. And because it is not equal to, we need to make sure we put dashes in here. So take your eraser and go put your dashes in your circle. Okay, so then we have to decide where to shade. And the best way to do that is to test a point. So I think the easiest point to test on any type of inequality is the origin, as long as your actual curve or line does not pass through the origin. So if I test the origin right here, and I substitute 0, 0 in for x and y, that would ultimately give me, I'm just going to test 0, 0. I'm going to write that right here. That would ultimately give me 0 is less than 49. And folks, that is true. So what that tells me is I need to shade inside this circle. And I'm not going to do it yet. I'm going to wait till I graph my lines, but I know I'm not shading outside the circle. I'm going to shade inside the circle. All right, so for the next one, we're going to graph the line y equals 2x minus 4. So we're going to go to -4 on our y-axis. Use a slope of 2 over 1. This one is less than or equal to, so we know this is a solid line. Now that we have it in slope-intercept form, since it's less than, we know that we're going to shade below that line, so keep that in mind. Whenever we go to shade this one, we know it's going to be below it. So what that does is that restricts us to this part of this circle right here, even though I'm not going to shade that. All right, and then the last one, we also have a line, and this line goes through the y-axis at -3, but it only has a slope of 1 over 1. Also notice that this one is just greater than, so we want to make sure when we draw this line that we draw it dashed. And guys, you should be using your rulers when you're drawing these. I can't use a ruler on this tablet. I wish I could, so mine aren't very pretty, but your lines should be pretty accurate when you draw them. And then in this case, it's greater than, so we know we're going to shade above this little dashed line. So we're inside the circle, below my blue line, above my pink dashed line. So ultimately, when we go to shade, we're going to shade this region right here. Those are where all the shadings would intersect. Make sure that we shade that and that part sticks out. If you shade everywhere, make sure that you always go back and shade the parts that intersect at the darkest. All right, so I want y'all to try the next one. Pause the video. When you're finished, start the video back. Pause now. So in this one, we have 2 circles. They're both centered at the origin. One has a radius of 6 and the other has a radius of 4. And the first one, because it's a less than r squared, we shade inside. And the second one, because it's greater than r squared, we shade outside. So it's going to kind of look like a donut, and you're going to shade in between. And that is the conclusion of this lesson. We will work on the practice together in class.